Okay, bring it left, slowly. Right there. Confirm, set it down.
Staging organizes incoming lots, so inspection and release follow traceable first in, first out control. Verify supplier lot documents.
A unique lot code anchors traceability from receiving through aseptic filling and dispatch. Quarantine prevents unapproved produce from moving into wash and preparation areas.
Opening one representative unit allows inspectors to assess pod freshness before sampling begins.
Visual inspection screens for mold, shrivel, and field damage that would reduce safety and yield.
Representative sampling reduces bias, so lab checks reflect the true condition of the incoming lot. Shelling exposes the edible peas, so analysts can measure composition instead of only the outer pod.
First, gently crush the shelled peas with a sanitized pestle to prepare the mash for bricks testing.
Soluble solids help operators judge raw material consistency before setting the downstream process.
pH is tracked at receipt because acidity affects process settings and thermal treatment validation later.
Defect grading shows whether the lot will deliver acceptable yield and whether extra sorting burden is likely.
Only lots that meet inbound criteria can move forward into washing and food contact operations. Controlled traffic reduces cross-contact and keeps raw receiving movement orderly as the lot enters processing. Hygiene zoning limits contamination transfer as raw produce crosses into the wet receiving area. Accurate positioning prevents sudden drops and protects delicate produce before the wash line starts. Controlled tipping feeds the line evenly and reduces mechanical damage before screening and washing. A uniform feed improves downstream debris removal and stabilizes the wash system load. Early debris removal protects pumps and wash equipment while keeping field waste out of the main product line. The flume transfers produce gently while beginning the first wet cleaning step. Flume loosens soil and spreads the produce for more uniform washing in later stages. Gentle air agitation frees attached dirt without the harsh handling that would tear fresh pods. Side stream screening removes soil and leaf fragments from wash water before the separated waste goes to treatment, never back to product. Dewatered transfer from the flume prepares the produce for the next rinse without carrying excess dirty water forward. A controlled single layer exposes more surface area so the rinse can remove loosened soil evenly. Spray rinsing removes the dirt released in the flume, so contamination load falls before the sanitizer stage. Drain logic keeps dirty water moving away from product contact surfaces and toward treatment.
Purification matters because sanitizer that is too weak or too strong can either fail hygiene control or damage product quality.
Produce enters a defined contact zone, so the hygiene step can be both effective and auditable.
Contact time is critical because sanitation depends on both chemical strength and exposure duration.
Controlled lift-out prevents excess chemical carryover and prepares the product for the final potable rinse. The final rinse removes sanitizer residue and leaves the produce ready for dewatering and inspection. Residual checks confirm the rinse did its job before the product advances to the next step.
Surface dewatering reduces free water, so inspection and sorting remain clearer and more stable.
Good drainage prevents puddling that can hide defects and carry extra water into preparation areas.
A quick post-wash check catches persistent soil early before the line moves into sorting and shelling.
Finer targeted rejection protects the next equipment from carrying unnecessary contamination forward. Controlled transfer separates washing from detailed sorting, while maintaining product flow and hygiene discipline.
Consistent presentation helps the sorter distinguish acceptable pods from damaged or foreign material accurately.
Optical inspection identifies color defects and foreign material faster and more consistently than manual sorting alone.
Precise ejection improves raw quality without stopping the line or disturbing acceptable produce.
Automated sorting reduces defect load, but a manual confirmation step still protects final raw quality.
A small surge buffer smooths feed rate, so shelling equipment runs steadily without overloading.
Controlled feeding protects shelling performance and reduces kernel damage before extraction.
Shelling separates the edible peas from fibrous pods, so each stream can follow the correct downstream route.
Initial physical separation sends the valuable pea kernels toward puree, while fibrous pod material is isolated for byproduct handling. This visible split locks the two usable streams. Peas stay on the food route, while pod fiber goes to drying and milling as byproduct.
After shelling, the edible peas receive their own wash because shelling can release juice, fragments, and remaining pod specks.
Fiber-rich pod material is kept separate from waste because it will be dried and milled into a stable powder product. Gentle washing removes loose shell residue and prepares the peas for final hand trimming and size-consistent grinding.
A final kernel inspection removes any lingering pod fragments before size reduction and pulping begin. Final manual inspection protects grinders and improves puree uniformity by removing stray shell fragments. A controlled feed hopper evens the product load, so the grinder receives a steady flow. Metered feeding prevents surges that could overload screens and create uneven particle size.
Grinding breaks the kernels into a pumpable mash, preparing them for pulping and finer separation. Closed transfer reduces exposure and moves the mash cleanly into the next refining stage.
Controlled pulper feed improves separation efficiency and reduces unnecessary product loss to reject screens. Pulping separates softer edible material from coarse fibrous residue, improving texture before finishing. Coarse edible fiber from pulping joins the existing byproduct stream for drying and milling instead of contaminating the puree.
The finisher narrows particle size further, so the product reaches a more uniform puree texture.
Finishing tightens texture control and removes remaining coarse particles that would affect customer specifications. Keeping all usable fibrous fractions together supports a consistent byproduct drying operation. Inline sieving adds a final protection step against oversized particles before deaeration and heat treatment.
Oversized solids are isolated to protect finished texture while still being captured as part of the fiber byproduct stream. Deaeration removes trapped air that can affect oxidation, pump performance, and thermal consistency. Reduced air content improves product stability and helps the pasteurizer heat the puree more predictably.
A buffer tank stabilizes line flow so downstream standardization and heat treatment operate without interruptions.
Gentle recirculation prevents settling and keeps the puree composition even before specification checks. In-process sampling confirms the line is trending toward the target texture and composition before thermal treatment.
Fiber must be dewatered before drying, so energy use stays practical and powder quality remains stable. Mechanical dewatering lowers moisture before drying and separates press liquor from the solid fiber stream.
Even bed depth is important because it helps the dryer remove moisture uniformly across the fiber.
Controlled drying stabilizes the byproduct so it can be milled and stored without rapid spoilage. Covered transfer helps contain dry particles and keeps the byproduct route clean and controlled.
Controlled feed prevents overload and helps the mill produce a consistent powder size.
Milling converts the dried fibrous fraction into a more uniform powder suitable for bagging. Sifting narrows particle size range so the byproduct powder packs consistently and handles better downstream. Coating maintains traceability for the secondary product just as strictly as for the main puree line. Wastewater treatment protects the facility and environment, and this stream never returns to the food product line. Sludge is managed as waste, contained, and removed without any pathway back to the food plant.
Clean in place removes product residues inside tanks and pipes, so the heat treatment line can be released hygienically for the next run segment. Once the line is verified clean, the puree can move forward to final specification adjustment before thermal processing. The blend tank creates a controlled hold point where the puree can be standardized to specification.
Uniform mixing prevents local variation, so composition checks represent the full batch accurately.
To ensure quality, we check the blend-soluble solids, logging the result right here next to the tank number and lot code.
Adjust solids by blending. Post-adjustment mixing ensures the final specification is consistent before the product enters critical heat treatment.
Closed transfer keeps the standardized puree protected as it advances toward texture stabilization and heating. Homogenization narrows particle variation and improves the uniform texture expected in the finished puree.
Stable feed is essential because the pasteurizer can only deliver validated treatment when flow remains controlled. The heat exchanger raises product temperature under controlled conditions as the puree approaches the validated kill step.
This is the critical control point where time and temperature must both meet the validated minimum for safety. The diversion valve protects the line by allowing forward flow only when the pasteurizer stays within validated conditions.
Documentation at the critical control point proves the thermal process was actually delivered, not just intended.
Post-heat sampling verifies the line after thermal treatment and supports routine microbiological monitoring.
Sterile transfer preserves the benefits of pasteurization as the product enters the aseptic filling zone. The aseptic surge vessel buffers the filler while maintaining a closed, sterile environment for the finished puree.
This line is locked to aseptic drums, with each sterile bag positioned inside its drum before product enters.
Aseptic filling transfers the finished puree into sterile packaging without recontaminating the product. Secure sealing protects the sterile barrier that keeps the finished puree shelf-stable in bulk packaging. Each aseptic drum is coated so the finished puree can be traced back through receiving, processing, and CCP records. Final automated checks verify fill accuracy and closure integrity before the product is released for shipment.
Stable palletizing protects bulk drums during warehouse handling and outbound transport.